Hello everyone. Motors have been in existence for the past century. We have put them to good use by propelling electric vehicles. I am Rishikesh Kulkarni and I am working as an electronics engineer at Pave Dynamics. I have been making electric vehicles for the past 4 years. I'll take you through the course of drivetrain fundamentals including motors, their controllers and the entire electric vehicle architecture. See you guys at the session. We know that electric vehicles are cars that run on batteries. It is those batteries that power up the motor and cause the wheels to spin. In this video, we will delve into the fundamentals of motor. The prime mover for electric vehicles is a motor. We would sure be interested to know a bit of a backstory for how we reached here. Electricity as a form of energy was discovered by Benjamin Franklin. While Franklin is always credited with the so-called discovery of electricity, he merely establishes the relationship between the lightning and electricity. In 1752, Ben Franklin conducted his experiment with a kite, a key in a storm. This simply proved that lightning and tiny sparks were the same thing. The first viable use of electricity was brought forward by Michael Faraday when he was able to establish a relationship between electricity and magnetism. A generator or an electric dyno was brought to the fore by around 1831. By the year 1834, Faraday was able to put in place a functional motor which rotated around its axis because of effects of electricity and magnetism, which we will explain shortly. The AC motor was patented by the year 1888. Meanwhile, in the late 1800s and the early 1900s, Thomas Edison and his arch rival Nikola Tesla were fretting over the supremacy of alternating and direct currents. Well, most of the electronics around us work on DC supply. It is much easier to use alternating current supply for generation, transmission and conversion. If you can see, there's a big empty space between the discoveries and inventions after the early 20th century and now. We will take a deeper look at this progress in the video on the topic evolution of motors. So before we can look into how motors work, we can brush up a few concepts of physics and specifically electromagnetism to get a hang of all the phenomena applied in construction and operation of an electric motor. The fundamental laws, principles, rules, or whatever you'd like to call them, we need to know are the Faraday's law, the Lenz's law, the Lorentz force, and the vector product thumb rule. Faraday's law basically explains the phenomenon of electromagnetic induction. It states that any change in the magnetic environment of a coil of a wire will cause a voltage, that is your EMF, electromotive force, to be induced in the coil. Here, we need to note that the cause of change is immaterial to the outcome, that is the generation of EMF. To put it in simple words, if a conducting element is in a magnetic environment and if any entity changes, it might be the magnitude or direction of the magnetic field or the conductor's motion itself. We should expect a voltage to be developed in the conductor. And if the conductor is a part of a complete circuit, it will result in current. Always analyze a problem in terms of cause and effect. It can be determined by the expression that epsilon, which is EMF, is equals to minus n into d phi by dt. That is, your phi is the magnetic flux intensity. Here, voltage is directly proportional to the rate of change of magnetic flux, denoted by phi. If we introduce equality, the RHS gets multiplied by n, which is the number of times a conductor is wound around in the form of a coil. The simplest real-life application of this rule or law is transformers. Transformers are two sets of conductors which are wound around a core. These two circuits are electrically disconnected, but energy is transferred between these two circuits via mutual inductance. When EC passes through the first coil, it produces an alternating magnetic field. The second coil is subjected to the same alternating field, which results in the generation of voltage and thus current. It is absolutely essential that the supply to the primary side coil is AC in nature. Transformers do not work on pure DC. Pure DC does not have any changing element, thus no field is produced to excite the coil. Please note that the understanding of a transformer is very necessary and essential to the understanding of working of a motor. Also, if you keenly observe this expression, you can notice a negative sign being placed besides N, which takes us to our next law, the Lenz's law. Lenz's law, named after physicist Emil Lenz, who formulated it in 1834, states that the direction of the electric current which is induced in a conductor by a changing magnetic field is such that the magnetic field created by the induced current opposes changes in the initial magnetic field. Lenz's law may be seen as somewhat analogous to the Newton's third law in classical mechanics. This law determines the direction of the effect because of a certain cause. In this case, the cause is the change in magnetic field. The effect is the induction of voltage. The voltage produced can possibly have two polarities. Now, the current which will subsequently flow through the circuit will have two possible directions. But the direction in which the current will flow will be in the direction in which its associated magnetic field will be opposite to the direction because of which the EMF was induced in the conductor in the first place. Thus, the effect is trying to negate the cause. To determine this mathematically, we introduce a negative sign in the expression for Faraday's law. Moving on, we come across the Lorentz force. Lorentz force or electromagnetic force is the combination of electric and magnetic force on a point charge due to electromagnetic fields. Here, a charged particle of charge Q moving will experience a force of the said magnitude when subjected to electric and magnetic fields. Let us consider the force experienced by the charged particle related to magnetism. The interesting point to note here is that the charge to experience a force because of magnetic field, it needs to be moving with a certain velocity v. It cannot be stationary. Thus, a moving charge per unit time is current. For current to flow, it will require a conductor. This law can be extrapolated to say that a current carrying conductor placed in a magnetic field will experience a force. The magnitude of the force is determined by QVB, where Q is the charge, V is the velocity with which it is moving, and B is the intensity of the magnetic field. I'll explain how to determine the direction of the force in a short while. The moving charge to the current relationship of Q into V can be replaced by I into L. The same magnitude can also be determined by ILB. Now we come to determine the direction of the force generated by the magnetic field and get to the last rule we need to ponder upon before getting into the motor. The relationship between the current and the magnetic field is of a cross product. Cross product can be taken of two vectors strictly. If you want to contest the claim that current is not a vector, I buy that. Current isn't a vector, but I dot dl is. The direction of this vector is the direction in which the current is flowing. Now we can take the cross product of vector idl and magnetic field B. The magnitude is already explained earlier. The direction of the resultant vectors will be perpendicular to the plane that houses the multiplicand vectors. Still, we are left with two possibilities of two vectors antiparallel to each other. To determine this, we outstretch our right hand, the four fingers and our thumb. Let the arm be the alignment of the first vector pointing towards the elbow. The second vector will be in the direction of the four fingers pointing outwards. In this arrangement, thumb points to the direction of the resultant vector. The important point here is that it has to be your right arm, or you might end up in the wrong direction. These four rules, laws, principle, or whatever you'd like to call them should be good enough for us to understand the construction and operation of motor. Well, we need to understand one more aspect of the rotating magnetic field but we will get to it on the go. In the next chapter, we will look into the construction of motor.